Саламатсыздар ма, құрметті студенттер. Алгебра есептен шешу практикумын ағылшын тілінде жалғастырамыз. Бүгінгі тақырып логарифмдік теңсіздіктерді шешуге арналады. Today we are solving logarithmic inequalities. Logarithmic inequalities are inequalities in which one or both sides contain a logarithm. When we solving logarithmic inequalities, we must keep some facts. If base a of logarithm greater than 1 and log base a of x less than log base a of I, then the argument x less than I. Precisely, the logarithmic function is monotonically increasing for this value a. If the base of logarithmic function a greater than 0 and less than 1, and logarithm base a of x greater than logarithm base a of I, then argument x less than I. Precisely, the logarithmic function monotonically decreasing for this value r. The argument of logarithm must be a positive number. So consider some examples. Example number 1, solve the inequalities of this logarithmic inequality. First, we consider the domain of the logarithmic function. The domain of the considered logarithmic function is a set of positive values of argument. So the both sides of inequality makes sense for these inequalities. The base of 2 of logarithmic function, it is increasing function. So when we isolating logarithmics, the inequality sign does not change. And given the given inequality is satisfied this inequality. Thus, the original inequality is equivalent to the system of these inequalities. To solve this system of inequalities, we consider each inequality separately. So consider them. 2x plus 1 less greater than 0, and move plus 1 to the right side as -1, x greater than -half. And next inequality greater than -3, and last inequality here. Combine the like terms, move x to the left side as -x, and 3 minus 1, x greater than 2. So by plugging each these points to the number line, we find the each solution of each inequalities and find the intersections of these inequalities. It is equal to this inequality. So the solution of the given logarithmic inequality is this interval from 2 to the positive infinity. So after considering next example, I erase this example. So next example. Example number 2. We need to solve this logarithmic inequality. So as you see in above example, you may conclude algorithm. First, we need find domain of logarithmic function, and next we need simplify, if necessary, simplify logarithmic function by using log rules, and next step, by isolating, we need transform the logarithmic inequality to the algebraic inequality. When we isolating the algebraic inequality, we must consider two cases as exponential inequalities, similarly to exponential inequalities. So the base of logarithmic inequalities greater than 1, the inequality sign does not change, and if the base is greater than 0 and less than 1, the inequality sign changes. So consider this example. First, we need to find the domain of this logarithmic function. It will be these inequalities of the domain of this logarithmic function according to the properties product rule and the identity rule. We transform the given inequality in this form to this form, and such as this inequality has same base of both sides, we isolate the logarithms. When we isolating, we look this base. In this case, the base of logarithm greater than 1, then the inequality sign does not change. So the original inequality is equivalent to the system of these inequalities. By solving each inequality separately, we find the intersection of this system. So the answer of the given logarithmic inequality is this interval from 3 to 4, including 4. Next, example number 3. Consider this logarithmic inequality. The domain of the definition of the inequalities is found like this condition, and according to the properties of logarithm, this inequality we rewrite in this form, and when we isolating, look this base such that the base of this logarithm less than 1 and greater than 0, the inequality sign changes. So the original inequality is equivalent to the system of these quadratic inequalities. By solving each inequality separately, we find intersection of this system, and the solution of the given inequality is equal to from -6, including -6, to -4, and from 2, 4 to 4, including 4. So we consider some examples. Solving here will be logarithmic inequalities. Logarithmic inequalities. So using this above algorithm, this above examples, you should be solve these given tasks. Of course, first in these inequalities, firstly you must consider the domain of this logarithmic function and look the base of these logarithmic inequalities. If the base of logarithmic inequalities is less than 1 and greater than 0, after isolating, the inequality sign changes, and in this case, this base equal to 10. That is the base greater than 1. After isolating, the inequality sign does not change. So that's all that I have today. Thank you for your attention. Сонымен бүгінгі сабақта біз логарифмдік теңсіздіктерді шешудің мысалдарын қарастырдық. Яғни логарифм теңсіздік шығару барысында ең алдымен анықталу облысын ескеруіміз керек. Яғни анықталу облысы бізде барлық уақытта оң сан. The domain of logarithm function, the set of positive values. Соны ұмытпауымыз керек. Және негізіне қараймыз. Түрлендіру кезде егер негізі бірден үлкен сан болса, теңсіздік саңбасын сақтаймыз. The inequality sign does not change. Егер кіші болса, 0 мен 1-дің аралығында болса, бірден кіші ол. Да теңсіздік таңбасы ауысады. Сонымен бүгінгі қарастырған негізгі логарифмдік теңсіздіктерімізді осы болатын. Тыңдағандарыңызға рахмет. Сау болыңыздар.